Hello, young people. Today I'm kind of combining two lessons. If you had the book or look in the book, today's lesson is kind of presented in two different lessons. I'm just going to go ahead and combine two lessons. And it's pretty much saying the same thing most of the time. Alright, so what we're going to do is discuss parallel lines and transversals and the angles that they create. We're going to start off with a couple of definitions here. A parallel line is lines that do not intersect and are coplanar. So that means in basic common sense they're on the same piece of paper but they never intersect. Skew lines are lines that do not intersect and are not coplanar. So they're not on the same plane, they don't intersect. We call those skew lines. So you can look at like this plane right here. Was that E1 or L1? I can't really tell. And this plane right here, they're actually parallel. They don't intersect. All right. But this is not a good picture. So I'll show you an example of this later. Parallel postulate. Geometry is full of these postulates and theorems. And these are the kind of examples I was telling you about that we need to understand these. We don't necessarily need to be able to quote them. If we were doing proofs, which is a big part of geometry, we would need to know how to quote them, but we're not doing proofs, so we just need to understand what they mean. Parallel postulate says if there's a line and a point not on the line, there's exactly one line through the point parallel to the given line. That simply means you got a point on the line, there's exactly one point that is parallel to that line there. And again, I'll show you this stuff later. Perpendicular postulate, if there's a line and a point not on the line given, there's exactly one line through the point perpendicular to the given line. Meaning, if I had a point somewhere, for example, if I had a point, that's kind of big, just out here somewhere. This point right here that I'm pointing at here, there's exactly one line that is perpendicular to this line right here. There's not 75 different lines. There's only one line that I can pull down here that will be perpendicular. And the same thing goes for parallel. There's exactly one line from this line to this point here that's parallel. That's all those two are saying. It's not necessary that we got to know a lot about that. That's just part of the definitions of how geometry works. Transversal is a line that intersects two or more coplanar lines at different points. Simply put, a transversal is a line that cuts into or intersects two parallel lines. Okay? It don't have to always be at that angle. It could be perpendicular, but it's transversal is simply a line that at least cuts two or three or four or five, but at least two parallel lines. All right? So today we're really going to focus on parallel lines and transversals and the angles that they make. But 3.1 talks about what if these lines were not parallel, and you really don't see that, but the names of the angles are still the same, so that's why I went ahead and grouped together 3.1 and 3.2. Now, depending on which teacher you have, they're going to make you memorize these. I think it's important to know the names, but what I think is most important is if you know what they are and how they respond or how they interact with one another. These are all definitions of the type of angles that you see here. And in the green here, you'll notice, and in some of these numbers, you'll notice which ones I'm referring to. Now, the names are very descriptive. Alternate interior angles. The interior of this picture that you see here is between the two parallel lines. So anything that's between the parallel lines, not just on this picture, but any picture, is going to be called the interior. And the exterior is going to be outside the parallel lines. So interior, 3, 4, 5, 6. Exterior would be 1, 2, 7, 8. Alternate, whenever you're talking about alternating, you're talking about on either side of the transversal. So here's a parallel line, here's a parallel line, here's a transversal. So alternate would be either side. So alternates would be 1, 3, 5, 7. All those are alternate with 2, 4, 6, 8. All right? So an alternate interior angle, if we put those two together, they're inside and on either side. And so you have 4 and 5 and 3 and 6 are alternate interior angles here. And what you need to know is that they're congruent. Alright? And this is with two lines that are cut by a transversal and two parallel lines. So they don't always have to be parallel. If you got the same scene and a line is cutting it but the lines are not parallel, the same thing goes. You can call them alternate interior angles, but they won't be congruent. But today's lesson, I want to focus on the fact that they're parallel lines and so that they are congruent. What are alternate interior angles? 4 and 5, 3 and 6. And what do you need to know about them? That they are congruent. Alternate exterior angles. Alternate exterior angles are angles that are on either side of the transversal, but they're on the outside. Remember, exterior was not between the two parallel lines, but on the outside. So alternate exterior would be 1 and 8 and 2 and 7. And what do you need to know about them? They're also congruent. Consecutive interior angles, or the same side interior angles. Alright, same side interior angles. Interior meaning between the parallel. Same side meaning right on the same side, not alternate. Those are inverses of one another. Alternate means opposite sides of the transversal. Same side or consecutive interior angles, which depending on which book they're calling that. So 4 and 6 are consecutive or same side interior angles. What do you need to know about them? Are they congruent? No. They are supplementary. What do we know about supplementary? Pause, pause, pause. Yes, they equal 180. So 4 and 6 and 3 and 5 are supplementary angles. They add up together to be 180 degrees. So consecutive angles is important to know. Consecutive, you know what that means, back to back, right after one another. Corresponding angles are congruent. So, what do you mean? Say corresponding are 2 and 6, okay? 4 and 8, same side. 1 and 5, you see that you kind of skip an angle on the same side. 3 and 7. So, if you skip an angle on the same side of the transversal, those are called correspondings and they are congruent. Now I want to show you this. I want to use my highlighter here and I want to show you what I found out about this. Alright? And that is that that's ugly color. Me no likey. Alright, so everything that I put in blue is congruent. Now watch this. Everything that's in the blue is congruent. So 1, 4, 5, and 8. Every single one of those. These are corresponding angles, 1 and 5, 4 and 8. 4 and 5 are alternate interior angles, and 1 and 8 are exterior angles. But every single one of those are congruent. Now, everything I put in the red is also congruent. 2, well that looks more pink than red. 3, 6, and 7. All those in the red are congruent. So 2 and 3, 3 and 6, 6 and 8. Now, what you'll notice is that whenever you have a red and a blue, those equal 180. But notice the straight angle here. That's a linear pair. 2 and 4 make a linear pair, right? So it should equal 180. 2 and 1 make a linear pair. That should equal 180. 1 and 3, a linear pair. That is 180. Now, 4 and 6, you just have to take the postulate's word, the consecutive interior or same side, that those two add up to be 180. But even think about it. On every single one of these problems, there's only going to be two numbers if you're dealing with numbers. Say, for example, this is 150. That means this is 150, this is 150, and this is 150. If number 1 is 150, what does that make angle 2? Wait, pause, pause. That's right. It makes it 30. Why? Because those two add up to be 180. How do I know that? Because they make a straight line and they're a linear pair. So if this one is 150 and this one is 30, that means this one is 30, this one is 30, and this one is 30. There's only two numbers in the whole thing. Once you find one, guys, you ought to be able to find every single one of these based on this diagram here. Alright. We'll come back to that. Let's actually do an example just kind of discuss some stuff real quick. I won't be able to do all of this, but let's look at this. It asks us to find a pair of parallel segments, okay? A pair of parallel segments. You have segment CF here, CF, and I write my F's backwards, so hush. And you have BE. That's an example of some parallel segments. But you also, AD is parallel to those two. A different set of parallel segments would be BC and EF. They're parallel, okay? And of course, this is new. Whenever you see this little arrow on the lines, those mean that those lines are parallel, okay? So you see those. You can tell those, but BC and EF are also parallel, and also AB and DE. But there's several. A pair of skew segments. They're not on the same plane, and they don't intersect. So BC and DE, maybe. They're not on the same plane, and they don't intersect. All right? But let's get down to what I really want to work on or look at. If you got questions about that other stuff, we can talk about it in class. They want us to give an example from the figure. Okay, what's a transversal here? The transversal in this particular picture is line Z. See that? Line Z right here? That's the transversal. Parallel lines are lines X and Y. Okay? Lines X and Y are the parallel lines. Corresponding angles would be angles 8 and 6 and 7 and 5 and 1 and 3 and 2 and 4. Oops, couldn't see that, could you? 2 and 4. All right, alternate interior angles. Alternate interior angles would be angles 3 and 7, okay, and angles 2 and 6. You see that? 3 and 7, 2 and 6. Alternate exterior angles would be 1 and 5 and 8 and 4. I got to move. Same side interior angles would be 7 and 6 and 2 and 3. All right, I want to get into problems like this because this is how it's going to show up. Find each angle measure, okay? They want me to find angle measure 1. And I know these two lines are parallel because they got those marks, so this is my transversal. If they're on the same side and you skip an angle right here, that means angle 1 has to be the same thing, 140 degrees. What's the name of it? I'm not necessarily concerned with you understanding what the name of it is. I need you to know that those two are congruent. But I think that's called corresponding angles. What is the measure of angle 2 here? The measure of angle 2, again, you on the same side of the transversal and you skip an angle, that means angle 2 has to be 70 degrees. Now they want us to find x. They actually want us to solve for x. But they give me an expression and a number. But what I got to do once I see this is remember that I have to set up an equation based on a true statement. If I skip over an angle here, like I've done, I skip over this. What is the relationship between this and this? Wait, pause, pause. Yes, that's right. They are congruent. They're equal to one another. So I set up my equation like that. Because I know that these two types of angles that are made by a parallel line and a transversal are congruent to one another. So I subtract 15 from both sides. And whatever that is, because I don't know it off the top of my head. Yes, 75. Oops, that's not 75 degrees. That's just 75. So x is 75, which makes sense. If this one is 90, then that one has to be 90 when you put that back in there. So that would make sense. One more. I don't know if I'm going to have time. Actually, I'm not, but I'll set this one up for you. X minus 30 equals 120 because that's the same relationship that they have. Alright guys, we'll stop right here and pick up later.